Here, two grippers transfer spools between processes. One gripper will place a spool to the gauge fixture, while a second gripper will unload the measured spool from the gauge. Bushings are automatically fed and installed into the C-pole and shell subassembly. Force and distance monitoring are used to ensure proper assembly of these components. The measured force and distance from the monitoring system is then written to the pallet ID tab. At the first stage in Station 6, the armature will be loaded over a pin by a robot. At the second stage, the servo press control sets the required pin armature dimension, then loads the correctly set armature subassembly directly to the C-pole on the pallet. Here, dual grippers retrieve the spool and body from the pallet and place it on the shell subassembly. It then grips the uncrimped body and shell subassembly and simultaneously grips the completed part in the crimp press fixture. A gripper retrieves the spool and body simultaneously and raises and inverts 180 degrees. A vertical slide with gripper then retrieves the C-pole and armature and then installs them into the shell subassembly. Then a spring is automatically fed and installed into the body, followed by a retaining ring. Here, the pallet ID tag will be queried. If the part is deemed good, the part is inverted, then the robot will transfer the inverted solenoid assembly to the wet line for testing. Rejected pallets on the dry side do not stop at this station for unloading. On demand, the next available functional tester will signal test finished to the robot. The robot then proceeds to the purge location, removes the purged part, and places the tested part to be purged. The test values are then passed on to the part traceability data collection system. This was another successful system solution by Wes-Tech Automation.